I am a PhD student of space physics and engineering, but what does that really mean? It's not something that I knew about growing up, and I don't assume that many people now know what it really means. But if you have a smartphone and you stream music, you use GPS to get around, or you use your phone for entertainment, or to look up at the sky and see where stars are and planets are and stuff, then you're already connected to space physics, whether you realize it or not. When I say space physics, I'm talking about the study of naturally occurring plasmas throughout our solar system and beyond. From the solar wind to planetary magnetospheres to distant exoplanet systems, we are trying to understand how stars and space environments shape the worlds around them. It is the processes that create the aurora, up north and down south. It's a coronal mass ejection, plasma launched from the sun, slamming into Earth's magnetic field just hours later. It's a solar energetic particle, accelerated during solar eruptions, penetrating a satellite's shielding and disrupting its electronics. It's a solar flare hitting astronauts who are on orbit and delivering a year's worth of career radiation in just minutes. It's not abstract, and it's not just science fiction. It's the realm of space physics, and it's happening all around us. When the quiet solar wind, the steady stream, not the storms, when it reaches Earth, it hits a region that we call the bow shock, straight on, and it gets diverted to the sides. From there, it continues to flow around the magnetosphere, away from the magnetotail, and off outward into the solar system. But when stronger space weather arrives, stuff like coronal mass ejections and co-rotating interaction regions, it compresses the magnetosphere. It's kind of like squeezing a balloon. This added pressure drives more energy into the inner magnetosphere through a process called the Dungey cycle. That's when things start to break. Radio signals bend. GPS becomes inaccurate, significantly in some cases. Satellites can start to take damage, and even the ground systems can feel the pressure from this dump of energy from space weather. Deep in its core, the sun fuses hydrogen into helium. It's quite literally the engine of our solar system. But that energy doesn't just escape. It takes over 1 million years to reach the surface, slowing down, scattering, pushing outward. When it finally gets out, it becomes a plasma, which is a stream of charged particles. We call that stream the solar wind. It goes away from the sun in all directions, but space physicists usually focus on the part that hits Earth. That happens in the plane of the planet's orbits, or something that we call the ecliptic plane. When the solar wind reaches Earth, we're able to study it using satellites that are positioned throughout geospace. The upper atmosphere often swells, and the layers shift in altitude, trying to balance the extra energy that's coming in. This changes how signals travel. Navigation, long-distance communication, even aviation is affected. These effects vary by location, by time of day, and by what the sun is doing. This isn't just happening here. We've discovered thousands of planets around other stars. Some are scorched. Some have magnetic fields and some don't. Some are locked in place with one side always facing their star. And some even literally rain metal. We study those systems too, because the same plasma physics that we see here at Earth seems to play out everywhere. What survives and what thrives depends on how that planet interacts with its star. Okay, so all of this, the space weather, the solar wind, the magnetic fields, it's not just theoretical, it's the real system that we live in. And understanding how that system is organized is really important for us to be able to use our phones and our laptops, to get on the internet, to use GPS to tell where we are. It's even responsible for keeping our atmosphere in place. We are not outside of space. We're within it, and we always have been. I didn't grow up thinking about this stuff. I didn't know it was an option for it to be a career. I didn't know that there were ionospheres, magnetospheres. I didn't even know there was a heliosphere. It's just not something I ever thought about. But now I get to think about it every day, how it impacts our technology and how it ultimately changes our lives here on Earth. This is the first of many videos I'll be making about space physics and space weather. If that sounds like something that you're interested in, then follow along with Heavy Brain Space. Thanks for being here, and if you like this, don't forget to hit like and subscribe.